Hi, this is Kishore, and in today's topic, what we're going to see is we're going to see how to use procedural content generation framework to create a modular buildings. Like because these modular buildings can be very much helpful for a quick level designing aspect. On that aspect, it is really a good option actually. If we have something created using the PCG method. So PCG is basically procedural content generation method. So let's start with our session. So first thing what I'm going to do is I'm going to start with a new project. Okay, so I'm going to choose a blank project and I'm going to name that as PCG, PCG building. Okay, so this is my project name. So let's first create it. And right now I'm not using any starter content. If at all it is required, we can even add it later because whatever option that you see over here can be modified later as well once your project has been created. So now the project is being created. Yeah. So initially, this is how it will look when we create a new project, and this is the default level or map that is being loaded. It's an open world, but we are not going to use this. So I'm going to create a new level. So go to File menu and type New Level. I'm going to choose Basic as basic level will have lights, default light setup will be there and a floor. So these are the actors that would be there when we choose a basic level. And on the top, you can see it is written untitled, which means it is not yet saved. So first thing is we need to save this level. Go to File menu, save current level as, and inside the content folder, I'm going to create a new folder and name that as maps. It's always good to organize your file. Okay, so inside maps, I'm going to create PCG. So this is going to be my level name, PCG for procedural content generation. And once we are done with it, the next thing that we have to do is we need to go to your edit menu and you have plugins over there. We need to enable a plugin. So the plugin that I'm going to enable is PCG. If you search for PCG, you'll get this procedural content generation framework beta. So we need to enable this plugin. Okay, it's a very important thing. So let's enable it, and it gives a warning message saying that it's a beta version that may affect the performance, stability, and all. So that's fine. So let's choose S, and once we enable any plugin, it'll ask us to restart the editor. So let's restart it. So once it is restarted, the plugin will be enabled, and we'll be start using our procedural content generation. So let's open our level that we created. Okay. So this is the blank level that we have. Nothing else is there, only the floor and we have the light actors by default, like skylight. We have a sky atmosphere, exponential light, or directional light, cloud, everything is there. Okay, now let's go to our content browser. And here I'm going to create another folder and I'm going to name that as blueprints. So inside this only all the programming logic I'm going to create. Okay, so here again right click on your content browser and let's go to blueprint class. And the first thing what I'm going to do is I'm going to create a blueprint class. Like the parent class will be an actor and I'm going to name that as BP. The naming convention BP stands for blueprints. BP underscore PCG. Okay, this is what I'm going to name. And let me just open it up. And let me close this plugins on the top, which we don't need now. Okay, so PCG, fine. So right now we don't have anything. The next important thing that we need to open is by right click. Once I enable the PCG plugin, I'll have this PCG option over here. So we need a PCG graph as well. So let me just open this PCG graph and I'm going to name that as PCG underscore building. Okay, now let's save. So it's important to save your files or say whatever changes that you're doing. No, it is good practice if you save it instantly. So we have the PCG building and we do have this blueprints. So let me open this blueprint now. Open blueprint full editor. So now I need a scene component over here. So we have a scene component and I need the scene component to be the root. Okay, so this is my scene component. So below that, let's add box collision. So within this collision, only the procedural content generation will happen. The building will be generated. Okay, so we have one box collision. Initially, the box collision looks very small. So we need to extend it. So on the right side, you have details panel. Over there, you have the option box extend. Click over there and let's put a value of 500 for all these three. It is 500. Once we are done with this box collision, let's add another thing which is known as PCG. Okay, so because we need to communicate with the PCG graph as well. Okay, so let's go to components, add, search for PCG. We'll have this PCG component. So this component is where we are going to select our PCG graph that we created. Okay, so select the PCG component over here, and on the right side details panel, you will be able to see below the instance tab, you will have graph. Select PCG building graph that we created. Now compile, save. That's all. So this is what that we are going to be done inside the blueprint actor. Let's close this. Okay. Now let me drag and drop this BP PCG into our level. Well, only then it will work, right? So if it is a blueprint class, then obviously we need to add it inside the level. So after doing that, let me open my PCG building that I have over here. Just double click and open it. Okay, so this is my PCG. So here, the first thing that I'm going to do is I'm going to dock this over here. Okay, so here only we are going to create the logic for the PCG. So before that, we need asset. Okay, so as we said, like we are going to do it for a building. So let's download asset from Quicksell. From the Fab Marketplace, I'm going to download. So let me just search for modular window and let me add Quicksell as a suffix so that I get assets from Megascan. So it will be easy for me to identify as well. So we have a modular window over here, but there are a lot of other assets also showing up, but I need only Quicksell Megascan. So let me choose Quicksell Megascan and then again search for that modular window. Now this will filter out all the assets that is being released by Pixel Megascan alone. From here we can choose it. Mm, I'm just looking out for a modern kind of thing. So let me search if at all anything is there, or else we'll choose something. I think this one looks fine for me. So let me select this. Okay, this looks fine. So let me choose this asset, which is over here, and I'm going to add that to the project. I'm going to choose medium quality, which is enough for me. So let me just add it. So once it has been added, make sure to save them. Just saving all. Okay, so we have the asset has been added now. This is for the walls. Okay, so similarly, we need to have something for the ceiling as well. For the ceiling, we will create or we'll download it later. But as of now, we have the window wall. So first we'll start with that. Okay, so let's go to our procedural content generation, and here we are going to get data from the actor. So get if you search for get actor data, so spatial, so this will actually collect the data from the selected actors, okay, because we are going to be using a blueprint actor and all, right? So based on that, we are going to create it. So get actor data. So from here, once we are into this, we need something else over here. Okay, so what exactly we need over here is we need another node that has to be communicated for the content generation. Okay, so for that, what I'm going to use is let me use a very simple node for that. After this, is my I'm going to add a volume sampler. Okay, so in that volume sampler, so because it's going to be created in a volume, okay, so that's why we have a volume sampler, and this volume sampler has voxel size over here. So by default, I'm going to make it a little big. Okay, instead of the default value, let me choose 300 over here, 300 for all XYZ. So this is what I'm going to do first, all 300, 300, 300. So once it is done, so if we want to see this, like we have a debug method. So on the advanced, if I click determination, so these are the details that has been related to this node. And here you can see debug. So using this debug, we'll be able to see inside our level as well. And there's a shortcut key also for that. So just select the node and click D on the keyboard. So D is for debug. Once you click this D, can you see the debug is enabled and there is a dot over here. Now if I go, so we can see. So this is the collision, and within the collision we have a box. It's just a debug, okay? So let's come over here and let's turn off the debug. Again, if you press D, the debug will go. And once we are done with it, now what I'm going to do is now we need to create the bounds modifier as well, because we need like it should be like covered all the four sides, right? So we need a bounding. So let's search for bounds modifier. So using this node, we are going to apply it for the trans for the transformation usually. So it will basically set the boundaries. Okay, so based on that. So now once we select this bounds modifier, the first thing that we need to do is we need to change the mode. currently it is scale. We need to choose set. Okay, so that it sets the bounds, the boundary. We need to set it first, and once we are done with it, the next thing that we need is transform points, because we need to transform those things, right? If I press D over here to debug and just to check, see right now I don't see anything much. So spatial data, that's fine. So let me search for transform points, the last option which is over here, transform points, choose that. So this is one transform point that we have. So we need like four sides, right? So we need four transform points. So this is the first transform point that I have currently. So this first transform point on the right side, you can see it has a lot of attributes like minimum, maximum, offset is there, rotation. There are a lot of things, okay? So based on that only we are going to create. So once we have this, we need to set the minimum and maximum offset for this, for the X value. Okay, so I'm going to give a random value of 150, the same minimum maximum like 150 over here. Okay, so these values have been tested values, so that's why I'm just putting these value over here. 150 for the first transform point. Now let me just duplicate that for the second thing. So the second should be like, it should be an offset to that, right? So instead of 150, now I'm going to choose a value of negative 150 for the X. Okay, so negative 150. Similarly for offset max also negative 150. By doing this, we get either both sides. So at 150 and negative 150, we have this. So let me connect this also over here. So 2 points are there. Similarly, we need to connect it. Okay, so one more thing is, so right now, even if I select this and press debug, I'm not able to see it over here. Okay, still it's a beta version only, so it is not fully being released now. Maybe because of that also we are not able to see the debug properly. That's fine. But what happens, like when we create this transform points, what it does is it creates the values over there. Okay, but the rotation and all should be fixed later time so that it will be helpful for us to fix it. So that we can do on the later part after we have the static mesh, the window that we downloaded, no? Modular window. Once we add that, we'll be able to fix the rotations and all. But as of now, what it happens, when we have only two transform points, what it does is it creates the volume. Okay. See, for example, if I choose this and press T, I'll be able to see this cube soon. See now. So what we will have is this entire portion or area will be filled, but this entire area will be filled, but the important thing is on the center, we don't want it to be filled. Okay. So on the center point, what I'll do is let me add let's say on the center point, I'll add something like this or that. Okay. So on the center point, what I'll do is let me let me add the difference node over here so that I don't have anything on the center. So I'm just going to drag a wire from there and just search for difference, spatial difference. And what I have over here is, so this is my source. I need to make a difference out of the other thing that is over here. So I'm going to connect this as well. Okay. So the difference is there. So by doing this, what it happens is it creates the gap on the center. So, but now we are not able to see because this has also been enabled. I'm just testing it out, whether this difference is at least working or we are not able. Okay, fine. Still, we are not able to see. Once we add the static mesh, that time it will be visible. Okay. So this is done. So now we need for the other two sides as well. So let me just again, let's go to our transform points. So let me just drag a wire and search for transform points. So the next transform point, I'm going to give the value on the y-axis. Okay. So this is going to be 150. The offset max also 150. So once after this part is done, I need another transform point. So let me just duplicate that as well. And for that transform point, it is going to be negative 150. Similarly, for the y value max also negative 150. Okay. So after adding this, the other thing is, as you guys guessed, it is the other difference node that we need to add. Okay. So, but this time I'm going to use this as my. So here also we have one difference and we need another difference node as well. Okay, because for this transform point, we have this as the source on this difference node. For this transform point also, we need the source. Okay, so again, let me add one more difference node. So for the second node, this is the source and the difference will be the first transform point. Okay, it will be like this. Similarly, over here also, we need that same logic. So this is my source and the second point is difference. Similarly, for the second transform point also, I need the difference node. And here, this is my difference. And make sure to connect this output as well from the bounds. So now we have four difference nodes over here. Okay. So we have four difference node and then we have all the values over here. It's all fine. So now after having all these things, one more important thing that we need to have is our we need to combine all of them. Like four sides are there and it's all like split into different things, right? So we need to combine them. For that purpose, we are going to use a node which is union. And we're going to combine everything. So let's connect all the outputs to the union input, which is over here. And once it has been connected, now the important part is after this union, we need a transform node. The same transform points we need because we need to adjust the offset of each sides of the wall as well. So for that purpose, I need a transform points. This one. Okay. So this is also done. So once we have all these things, so the next thing is a very easy thing, which is our static mesh because we need to add the static mesh over here. So let me drag a wire and search for static mesh spawner. So I got the static mesh spawner. Now inside the static mesh spawner, let me save it till now, whatever we have done. So this is our graph you can see. In the starting, we got the data from the actor and then we made the volumes. So as a clock points and then we made that points into bounds so that it is only fixed on the corners. And these are all the transform points because we need each transform point for each side of the wall. And the center part, we don't need anything. That's why we were using this difference node. Only the corners will be there. And then apart from that, the statics mesh spawner is also there now. So inside this, now we need to add the static mesh. So select the node, and on the right side, if you come in the attribute section, you have mesh entries. Okay, so click the add element button over here, and inside the descriptor, you will have static mesh option. So right now we have only one static mesh which we downloaded from the Fab marketplace. That is what we have. Let me save everything. Okay, so we have added it. Now let's go and check how it's gonna look. Can you all see like how it is looking right now? The rotation, everything is completely, it looks like a mess. Okay, we can see whatever that we have right now, it doesn't look good at all. Okay, so we need to fix these things. So for that, what shall we do is, and also make sure this bounce has been set to set. Fine. So for each point, we need to edit now. Okay, so we have these transform points, right? So let's start from the last transform point that I have. So on this transform point, the rotation part we need to fix it here. So I'm going to give a rotation value of maybe negative 90 and negative 90. Let's check. Yeah, it's changing. Fine. The side, okay, fine. Let's move on to the next one now. I'll choose the other transform point that we have. For the third transform point now, I'm going to give a value of the rotation minimum 90 and the rotation max also 90. Now let's check. Yeah, so the other thing is also being rotated, you can see. So that this side also is there, it is also on the other side. Good. Now for the next transform point. So here we need to rotate it, like flip it actually. So rotation, we have to flip it on the front side as well, right? So for that purpose, I'm going to give a value of 180 and here as well 180. Now let's save all. Okay, now you see. Now this looks fine. Okay, like okay, fine. So everything looks fine for now. Okay, but here in the bounce value, there is a small trick. Okay, as of now. Because till now we didn't do that. And also you can see the bounce minimum and max value also we need to set. So here I'm going to put negative 100 for the minimum bounce. Here also like negative 100. And for the bounce max, I'm going to put 100, positive 100. So now let me save and check. Let's see. Okay. So it has been, you can see exactly on the center, we don't have anything. And everything is around the corners only. Fine. So, but still the alignment is required. So that's what we're gonna do next. So now next thing what we're going to focus is the offset that has to be fixed. And that offset has to be fixed using the transform node that we have. Okay. So after fixing all the four transform points which are over here, so the next thing that we need to fix is the other transform point. So for the first transform point, we don't need to fix the rotation. It is fine. Whatever the rotation is over there, that is fine. But now let's fix for this transform point. Also, we need to give the rotation. Let us check. For minimum, I'm going to put a negative 90, and here also negative 90 for the max. Let's save and check. Yeah, so things looks fine now. We just need to adjust the offset alone. Okay, for the orientation, rotation, all perfect now. It's coming perfect. So only for the offset we need to fix it. Okay, so let me come over here and on the Y value, let me just first fix it. Okay, so I'm going to put a value of 150, here also 150. Save, check. Yeah, it looks closer. Now still we need to fix these corners. Okay, so on the x-axis also, let's give a value of 25 and 25. Let's check it. Yeah, it is a bit close, but still we can add or we can correct it. Instead of 25, let me give a value of maybe 40, 40. Let me check. Perfect. This looks perfect. That's all. We have a building which we created through the procedural content generation method. So we can see we can lift it. If I want to scale, I can simply scale it. See, so it's a very quicker thing to create, and also it is very helpful for level designing purpose. The multi-story building can be created so easily now. Yeah, this is fine. This looks amazing. So let's fix the ceiling part as well. Okay, so for the ceiling, first thing is we need a static mesh. Let's create it. Instead of downloading it, we will create it using the modeling mode. So go to the modeling mode, the create, I'll choose a box, and by default, this is the box size, but we need to modify it, okay? So let me add it. So I'll come over here to the shape and don't need the height to be this much. So let it be 25 is fine, I guess. This much thickness is fine. And for the width, I think I'll use 200 and 200 so that it is a bit big. Let's accept it. So this piece I'm going to use as my ceiling. So let's first find it in our content drawer where exactly the source mesh is. So select it and press Control B. So it will show you where it is in the content drawer. So here I'm going to right click and rename this as SM underscore ceiling. So this is my ceiling. So I'm just make sure that I rename it properly. Okay, so this is fine for now. Now the same process we need to add this to our ceiling. Okay, so let me come over here. So near this bounce modifier, I'm going to just create another bounce modifier, and from the bounce modifier, obviously what we need is first the minimum maximum size also we need, and also we need to put the mode to set. Here the minimum size I'm going to take -50, -50, and -50. And on the other side it is like +50, +50, and again over here as well it is +50. Okay, so X and Y 50 is fine. Now apart from that, what I'm gonna do is we need the same, like we need the transform node now again, so that it will be fixed as well. Okay, so we need two transform nodes over here. Let's take it for the transform points. Let me duplicate this using Control D. And I'm going to connect this. The binding axle here. So here, the top one which is over there, no? So only for this I'm going to change it. Okay, so even if I press D again, let me just check whether, yeah, see, you can see the point clouds now. So it is actually like this. Okay, so the center, fine. Let's come over here. For the bottom thing, I don't need it. Let it be all default 000. Only on the top one, I'm going to change it. So after changing this, what we need to do is we just need to look out for the difference because on the center part we don't need, right? Let me choose difference. Let me connect this and after doing this, now you can see the changes. Okay, okay, the difference we don't see it over here. Fine. Let's choose this and of the debug thing. So after the difference, what node we are going to use is again transform points for the offset. Okay, so once it is done, the next node that will be adding will be the static mesh spawner so that we will attach our ceiling over there. So we have the mesh entries, add the array element, just expand the index 0 and also expand descriptor. And inside this, the static mesh, I'm going to choose SM ceiling. Fine. Let's check how it's gonna look now. In this transform point, we didn't change at all. That's why. If I just change that to 300 and 300, now we see, the ceiling is there and it got fixed. So the only thing that we need to adjust right now is on the Z axis of the ceiling because it looks a bit on the upward thing. So let me just come over here. So in this transform points, the scale is because if at all the scale value is default 1, you see how it looks. So so now what we have to do is I just need to increase the scale value as 1.5 in the minimum and 1.5 in the maximum as well. So by doing this, it looks like this, like one ceiling it will look. And also now on the offset, so on the z-axis, I need to change it. Okay, so for the z-axis, we need to change. Then I think like 50 would be enough. I guess like negative 50 or something. Let me just check it. If we put 50 and 50, okay, let me put both as negative 50 and negative 50. Let's check now. Yeah, fine. So I think this looks perfect. The only thing that is missing is we need a color on top of it. Okay. So then that also we can just download it from the Quixel itself. Like we'll just download a paint and just search for ceiling. What it's gonna give, I don't know. Let's search for ceiling, damage ceiling, concrete ceiling, liquid. Maybe I'll choose the soundproof ceiling for now. No, not this. I think a normal concrete itself, let's choose for now. Medium quality is fine. I'm just adding it to my project. So this material, I need to add it to my static mesh itself. So I'll open the static mesh editor. So here I will add the material. Yes, so this looks fine. Maybe the tiling can be adjusted later. So now we can see I have this. Now let me just duplicate it and you can see like exactly it matches and it is the overlapping is not there. It works really fine. So using this, the level design can be like very quickly done. Let's try it out. And just modifying it. So like this, some interesting designs can be made, like something very interesting can be made very quickly by using these PCG tools. So thank you guys. So that's all for today's class. So we'll meet on the next class with another topic of PCG, the Procedure Control Generation. Thank you all.